My name is Haidang. Today I'm presenting GANSlider, how users control generative models for images using multiple sliders with and without feedforward information. This work was done in collaboration with my co-authors Lukas Mecke and Buschek. Recent tools have already demonstrated the interactive use of generative image models for the creation of new digital images. Typically, the slider interface has been the prevalent user interface to manipulate semantic image dimensions. In case of editing a face, these semantic dimensions may represent the facial expression, such as smiling or frowning, or it can represent things like the facial age or the gaze direction. GANSlider by Herkkonen and colleagues used principal component analysis to automatically discover semantic feature dimensions in the image space and then map these dimensions to individual sliders, one per principal component. In another study by Ross and colleagues, the authors evaluated the interpretability of different generative models. In the study, the authors introduced the reconstruction task, where users were asked to match a picture to a target image by adjusting the sliders on the left. Note that in this example, the sliders didn't carry meaningful labels, which makes it difficult for the user to make informed decisions beforehand. On the right side, the authors displayed the current alignment percentage. However, they have found that some participants have exclusively focused on this feedback and paid less attention to the other elements of the user interface. Although frequently used, the slider interface has not been studied in depth from an HCI perspective for the control of generative image models. So to better understand how users are working with sliders to control the semantic output of generative image models, we need to fundamentally understand which design choices may influence the user's interactions. Although it's often assumed that each slider can be mapped to a highly disentangled semantic dimensions in the latent model space, disentanglement usually requires extensive optimization efforts and is therefore not always available during the early phases of the model development process. And because of that, the slider interface may pose additional interaction challenges, such as not knowing which sliders to adjust. We therefore built a prototype that provides feedforward images for each control dimension. In our online study, we recruited 138 participants via Prolific. We focused on two variables of the slider interface. First, we vary the number of control dimensions to evaluate how users interact with the slider interface with increasing complexity, where complexity is described by the degree of freedom with each additional slider. Secondly, in addition to the regular slider, we introduced another variant, which we call the film strip slider. For our prototype, we use principal component analysis similar to GANSpace to automatically extract control dimensions. We do this to strike a balance between complete random dimensions on the one hand and fully disentangled dimensions on the other hand. For each control dimension, we then sampled points with different standard deviations from the initial image seed and along the principal axis. We then decoded them using StyleGAN2 and embedded them as preview thumbnails in the film strip slider. For our user study, we employed a task similar to Ross and colleagues, where each participant was given the task to modify an image to match a target by adjusting the slider interface. They could either try to solve the task or skip it if they could not solve it. We decided not to include feedback on how close the participant was to their goal, since we wanted the user to focus on the sliders and the target image. Each participant worked with both the regular slider and the film strip slider with increasing numbers, starting from a single one and ranging up to 10. Whether the participant started with a set of regular sliders or film strip sliders was counterbalanced. After each reconstruction task, the participants had to fill out a short questionnaire that included questions rated on a Likert scaler and a NASA TLX test to measure mental workload. In addition, we logged each user interaction with the slider and how long users required for each task. We have not found significant difference in the completion time between the regular slider and the film strip slider variant. Nor did we find that the final results of the image was closer to the target image as measured via the combined displacement of the sliders from the target positions. However, we also looked beyond those measures to better understand how users were interacting with the slider interface. We observed fundamentally different interaction patterns depending on which set of sliders the users were working with. They were more strategic in the decisions which slider to adjust next when using the film strip sliders. Each cell in this graph represents the probability of switching from one slider with the IDs given in the rows to another slider with the IDs given in the columns. The high transition probabilities on the diagonal for the regular slider variant means that users naturally adjusted the sliders from top to bottom in the absence of the visual information. We have also observed significant differences between the slider variants where users overshot the target value for a given control dimension more frequently and required more unnecessary interactions when working with the regular slider. We have further found that users were quickly overwhelmed with the increasing number of sliders. In particular, Ross and colleagues have recently shared the expectation that interacting with all dimensions simultaneously may be overwhelming for models with many tens or hundreds of representation dimensions. Our analysis and people's feedback here indicate that this can become challenging already with about 5 to 10 dimensions. In conclusion, we have investigated the impact of different numbers and types of sliders on users' interaction behavior and performance in an image reconstruction task with a generative model. Overall, we have found that exposing users to more control dimensions steeply increases the number and complexity of interactions. We have also found that measures beyond task completion times and overall success rate are crucial to characterize the impact of different UI designs. Our results challenge the HCI and AI research community to further investigate the UI design space for interactive generative models. While regular sliders are frequently used, there's still room for improvement, and the film strip slider is one step in that direction.